Hello guys, today we're going to study 4.3 properties of logarithms. So if you look here, we have properties for expanding, be careful on this word, expanding logarithm expressions. So we'll say m has to be greater than 0, n has to be greater than 0. So here we have a product rule, we have a quotient rule, and a power rule. Let's look at each piece really quick, okay? So if we have product rule, that means if you have something multiply, then here we're going to add. The second one, we have m over n, and then we're going to subtract this piece. And then we have the power rule. If you realize it's a power rule, we actually just bring this p to the front. So you can pause this video and then copy them down and then take a look. Example 1, we have use the product rule to expand each logarithm expressions. So we know we have to use this product rule, right? So let's go ahead and look. We have part A, log base 4, and then we have a 7 multiplied 5. The words tells you expand. That's why we're not going to multiply them. Okay guys, so let's go ahead and plug it in by using the product rule right here. So we're going to have log base 4. M is 7 in this case, and then plus log base 4, and then the n in this case is 5. So I just highlighted it really quickly. Hopefully that helps you to understand this. Alright, so let's go ahead and look at the second one. So for part B, we have a log. This is a common log, right? Because if we write this form, the common log 10x. Again, it's expanded, so we're going to have a log 10 plus log x. So the base is a 10, so that's why we write this as common log. And then you have to realize log 10, okay, we have to think log 10, can we simplify it? Log 10, 10, right? 10 to the what power give you 10? It's just going to be 1. So log 10 is 1 plus log x. So that is my final answer. Example 2, we have use the quotient rule. Alright guys, I just wrote down the quotient rule on the right hand really quick. Hopefully that help you. That's my quotient rule, and the dividing just going to be minus. Let's go ahead, part A. We have log 7, 19 over x. Okay, so we have dividing, we're just going to have log 7, we have 19. We're going to subtract log 7x. And then you look if you can simplify. So in this case, there's nothing I can do. That is my final answer, part B. We have a natural log e to the third power over 7. So that is just going to be natural log e to the third power minus natural log 7. Again, all we're doing in this case is just plug in a formula. There's really nothing else. If you think of part B, we have natural log, we have e. We said anytime we see them, we can simplify, we'll just cancel those. Then you're going to get 3 minus natural log 7. That is my final answer. Example 3, using the power rule. So for example 1, 2, 3, it tells you exactly what rule to use. Okay? So power rule, I'm going to write it on the right hand side just in case you can't remember. So if you look at part A, we have a log base 5, 7 to the fourth power. So all I have to do is just bring this to the front. Then that gives us 4 log base 5, 7. So you look if you can simplify. In this case, we can't. So that is your answer. Look at part B, we have natural log square root of x. So square root of x, I can actually write this as x to the 1/2 power. Okay, hopefully you can remember, or you can think here we have 1, outside we have invisible 2. So that's why you're going to have x to the 1/2 power. So I'm going to rewrite this as x to the 1/2 power. And then now we can use the power rule, bring this to the front. You get a 1/2 natural log x. So that is your answer. Let's look at part C. So we're going to have log, this is a common log, right? Log 4x to the 5th power. Again, we're using power rule. They already told me to do that. So we're going to have a 5 common log 4x. Okay, again, think what can I do? Can I simplify anything? The answer is no. So that is my solution. So very straightforward. Example 4, expanding logarithm expression. So for this question, if you read this, we have to expand this each expression as much as possible. Part A, this time they didn't tell you what method to use. Okay, so we're going to just rewrite this piece and think of what we have to use. Remember, we have a product rule, we have a quotient rule, and a power rule. Okay, so if you look at this, first we can think here, alright, the parenthesis, inside the parenthesis we have x squared, we also have a square root of y. That's between is a product. So we said if we have a product, we can use the product rule. We're going to have log base b, my m in this case is x squared, and then product rule tells us is a plus log base b and then square root of y. And then let's go ahead and look at if we can do anything further, because we have to expand it as much as possible. So now I look, okay, I have actually a power right here, right, which means I can bring this to the front. And then we also have to rewrite this square root of y to something, right? So I can rewrite this piece as what? Actually, we done it early. We can rewrite the piece as 1/2, which means we can bring this to the front as well by using the power rule. So now I can rewrite this as 2 log base b x plus 1/2 log base b, we forgot to write y. Okay, y right there. So you check again if we can simplify anything else. In this case, no, so that's why that is my answer. Alright, for part B, let's take a look. We have log base 6, and then we have cubic root of x over 36y to the 4th power. So if you look at this, okay, we have a two piece. One is we're going to have a quotient rule, right? Because we have a m over n form. Another piece is, hopefully you realize 36 multiply y to the 4th power, that is actually product rule. Okay, so let's go ahead and use the quotient rule first. So I'm going to do is I'm going to write log base 6. I'm going to rewrite this x as x 1/3 power over 36y to the 4th power. Okay, so from here we're going to use the quotient rule. That will be log base 6 x to the 1/3 power minus log base 6 36y to the 4th power. And then here we're dealing with a product rule. Let me highlight this part. That is a product rule because between is multiplying. And then now what I can do is I have a 1/3 power, right? So I can bring this to the front. We're going to have 1/3 log base 6x. Then I have to continue dealing with the second part. So now we're going to deal with the product rule. I'm going to put a parenthesis right here. We're going to have log base 6 36 plus log base 6 y to the 4th power. Alright, then once we have this piece, now we're just going to simplify it. That will be subtract log base 6 36 and then subtract again log base 6 and then y to the 4th power. So now we look, can we simplify further? This piece right here, 6 to what power give you 36, which is a 2. So I can simplify this as 1/3 log base 6x minus 2 minus, remember you have to expand it as much as possible, so we have a power right there. So we're going to bring this 4 to the front. That will be log base 6 and then y. So that is my final answer. Take your time, pause the video, make sure you understand it. So here we have properties for condensing. Okay, I highlight this part because earlier we're expanding. Now we're going to do condensing, which is the reverse of what we have done. Okay, so we say this coefficient of logarithms must be 1 before you can condense them using the product and the quotient rule. Okay, let's look at example 5. So let's understand what they're saying here. So if you look at example 5, we have a 2 natural log x plus natural log x plus 1. Okay, so I look at the coefficient for my natural log x. That actually is right here. That is 2, which means that against what we're talking about, right? So we can't have this as a 2. So which means we have to apply the part rule first, bring this back to the exponents, which means we have to rewrite this as natural log x to the second power, then plus natural log x plus 1. Now I look, both coefficients are 1, so I can apply the product or quotient rule now. So since between is a plus sign there, so I know I must use the product rule. So I'm going to write natural log. Remember, my m in this case, if you have to look, my m in this case is x squared, and my n in this case is x plus 1. So that is my final answer. Okay, example 6. Condensing logarithmic expressions. Write as a single logarithm. Okay, part A, we have 1/2 log x plus 4 log x minus 1. Okay, we always have to apply the part rule first, because we can't have this as 1/2 or 4. It must be 1. So we're going to apply the part rule first. That will be log x to the 1/2 power, and then plus log x minus 1 to the 4th power. Because the plus between, we said we can use the product rule, which means we're going to have log. Okay, product rule tells me I'm going to have x to the 1/2 power. Then we're going to have x minus 1 to the 4th power. Close the parenthesis. So here is my solution. Okay, part B. I'm going to write it right here. We have 3 natural log x plus 7 minus natural log x. Okay, so again, we have to apply the part rule first. If this coefficient is not 1, so we're going to write this as log x plus 7 to the 3rd power minus natural log x. Now we both have a natural log. Then I realize it's between, it's a subtract. That means we must use the quotient rule, which is natural log x plus 7, this whole thing is cube, over x. I can put the bigger bracket here. So that is my final answer. So here we have part C. 4 log base b x minus 2 log base b 6 minus 1/2 log base b y. Okay, we have a subtract and subtract. So no matter what you do, make sure the coefficient is 1. So we're going to have to move each piece. There's going to be part rule here. Then we're going to move this part rule, and then we're going to move this piece part rule. So here we have a subtract. I'm going to deal with this one, okay? So which means we're going to have log base b. We use the quotient rule. We're going to have x to the 4th power over 6 to the 2nd power. Then subtract log b y to the 1/2 power. Here we use the quotient rule. Of course, we shouldn't know what's the 6 squared, just going to be 36. That will be minus log base b y 1/2 power. Now we have another subtract. Now we're dealing with another quotient rule. So I'm going to have log base b, that will be x to the 4th power over 36. That is actually my m, right? The whole thing is my m, over y to the 1/2 power. That is my quotient rule. So again, if this doesn't make sense to you, just wait a minute. Okay, look at the right hand side. I wrote it down. Okay, so because this is a little bit complicated, I'm going to highlight this. We have this m right here. So in this case, we're going to have the whole thing as my m. Right, this is my m. And then here we're going to have our n. So that is our n. Hopefully that makes sense to you. So now we're going to simplify it a little bit more. Log base b, so we have this divided by something, which is a y 1/2 power. That is the same thing as, so multiply the reciprocal, and then we simplify this, that will be log base b. So that will be x to the 4th power, and then we're going to have a 36 y to the 1/2 power. So that is your final answer. Some of the people ask me this. You can write this in this form as well if you want to, okay? So either one's fine. Okay, that is our answer. So that is our method 1. So, or we can do the part C. I'm going to copy down the question from here. Okay, so because everything that's the same so far. Alright, so all I did is just copy down the first steps over. Okay, so I'm doing the method 2. So if you think about this for a minute, if you think this, okay, I actually can do this. I can actually rewrite this as a minus. I'm going to put a parenthesis here for those two pieces, because I'm going to take a negative sign out, and then what happens here is I'm going to end up there adding, right? Because I take a negative 1 out, and then we're going to turn this into this form. Adding means we're going to use the product rule. So now what I'm going to do is I'm going to apply the product rule first. So product rule kind of is easier. That will be just going to be log base b 36 times y to the 1/2 power. Okay, so this is the product rule we get here, and then now you look, I can use the quotient rule. Okay, we're going to have log base b, and the quotient rule tells us x to the 4th power over 36 y to the 1/2 power. Okay, if you look at this, the right side and the left side, they both get exactly the same answer. I think a method 2 is much easier than method 1. Okay guys, that is part C. Use a different method. Whichever you prefer, you can use that method. Alright guys, here we have the change of base properties. I don't want to read the whole thing, so go ahead and pause the video and then read this formula, okay, and then copy them down. So I'm just going to show you how to apply those properties. Here we have example 7, changing base to the common logarithms. Okay, so we're talking about the common logarithms. We're going to talking about the first one. We're going to evaluate log base 5 of 140. Okay, so I'm going to highlight this each piece. So our base is, we set this b. Okay, and I'm going to highlight my m is 140. So then now what I'm going to do is I'm going to apply this. That will be log. Okay, we're going to use common log. Log m is just going to be log 140 over log b, just going to be log 5. Okay, again we're going to highlight each piece. Hopefully that help you to make a connection. Okay, once we have this, so use a calculator, you're going to get around 3.07. So that is your answer. Example 8. So change base to natural logarithms. So again, so we have this log base 5 and then 140. We want to use the natural logarithms, so we have to use this second one. That means this is going to be equal to natural log 140 over natural log 5. You plug in the natural log 140 over natural log 5, you're going to get actually exactly the same as 3.07. If you evaluate something, you definitely should get exactly the same answer. Okay, just make sure you read your question. Sometimes they want you to use the common logarithms, sometimes they want you to use the natural logarithms. Okay guys, thank you very much for watching the video. I'll see you guys next time.